take painkillers right before the stream. It's like, you know, normal people need alcohol to feel like this, but I just do it by spending like 7 hours continuously working on a compiler. Because yesterday's stream for that algol 60 compiler was like 5.5 hours until 11:30, and then I actually finished the feature that I was working on after the stream at like 1 in the morning. So you know what? I'll show that here, even though we're going to be doing game design today. But okay, so what I was doing yesterday was basically getting functions that can take functions and then call the function that it takes as an argument. So here I'm testing a print function with add, which is this function here, and a multiply, which is this function here. So it should just print the results of 10 plus 12 and then 10 times 12. And I got it working. And I knew I got it working because I actually tested it literally while I was on the BRB screen just to make sure that I wasn't going to make a fool of myself. But anyway, we're not here for compilers. We're here for video games, which are substantially... Well, honestly, they're both kind of like black holes in terms of like the amount of stuff that you have to do. I guess it depends, like... I guess it depends, one, how much control you're willing to give someone else, and two, what complexity you want. But yeah, I feel just terrible. Well, at least physically. I'm honestly in a pretty good mood. Oh yeah, I also added lights because I was gonna take a video of this level, but it's still kind of jank. So what I'm gonna do, first thing first, I want to run through this a few more times. In part just to get like a good market, like a good little clip that I can share online, but also just because I want it to look, or want it to feel good to play. Well, that's not the take. Oh yeah, you know what? Let's start with... So I mentioned that I wanted the timing of this to be slightly resynced, where I pushed the entire loop back about a second, so that way the player can actually get onto the... Take your time, Godot. Take your time, Godot. Jeez. All things should happen instantaneously no matter how complicated they are. That's my rule on computers. But okay, so eventually we're gonna need basically all of these tracks to be removed. And because we're gonna need to resync and reconfigure all of these. And eventually I need to make the looping a little bit more graceful, where like... Because right now there's no reason it should be 10 seconds long. It was because I had to push everything back like 2 seconds. What the heck? A plays it backwards. Oh, it's like WASD for the controls on this. That's weird. Oh well. So this is what I want, basically. But then how do I make that... I know what to do. Keyframe all the... well... I guess we can just... So, what are the things that we actually need? We need... the transforms. I wish I could filter, like, because there's only a few keyframes that are actually crucially important in this. They are the positions of these relative to each other. I guess the top 3 things, or these top 3 nodes here, are the tracks that we actually need to pay attention to. Because basically I want to compress this loop as much as possible without negatively impacting the actual things that are important. So I think I can just move this whole thing back to like here maybe. And then I can compress this to 10 seconds. So that gives us 1 second. So basically, the player jumps onto this thing once it's actually up in the air. Yeah, they jump from here to here. And then they jump from there to there, and they jump onto that thing. So also what I'm going to do is I'm going to make this lift faster, because we don't need, once we're lifted up like this, so I'd say right here, I can start compressing all of this stuff together. Because the player is meant to basically get onto this thing right, yeah, I'll say right, like there or so. So we can probably push all of this back by like half a second maybe. And then yeah, the player jumps right there, jumps, bump, hit there, jump, bump, hit there. So I guess this is about as short as I can get it. So I've made it precisely 1/2 second shorter. Finally, the player will only have to wait 9.5 seconds if they miss the loop. They won't have to wait 10. But admittedly, my intended way to play is the player just resets at their checkpoint if they miss the jump. So hopefully so I'll have to make sure that they're actually taught that by this point. Oh yeah, and then the other thing today I should probably do is fix the broken ass ledge jumping on moving platforms. Well, almost. It feels like sometimes my input, I guess I kind of sometimes don't agree with when it chooses to make me crouch versus roll. I might have to do what someone suggested I make just crouching and rolling separate buttons. There's just so many buttons in the game already. Yeah, I see the main issue is when you ledge jump, it doesn't apply the velocity of the ground onto you. So I think this loop is generally where I want it to be. I just need to now fix the broken ass ledge jump. So where is that? Ledge jumping. Let's do, I think I'm gonna try these two. Ledge jumping on moving platforms is broken. I think this will be the easy one. And also, I want something for the player when they get damaged. So let's do base mesh. So let's have the player... Oh, how do I do this? Oh, I know. All of these materials need a material overlay. So let's make a new shader. Is this correct? Kind of works. And then render mode unshaded. So it's not really overlaying properly. Oh, there it is. Okay. And then hair also needs this. So we need export material var material. Well, I think what I gotta do is I gotta make the player damage material a special thing. So we gotta do let's save this material. This will be like damaged. And this one. Oh. Can I like save this? Make it unique, then save it. Player damaged.gd shader. Oh yeah, eventually, because I am planning to eventually port this game to Godot 4, I gotta remember to rename all of the material or all of the shaders to GD shader, because Godot does not automatically do that. Or no, it does automatically rename the file. It just breaks all of the references to materials, so I have to remake every single material in the entire game unless I fix it now. But that'll be for later, because I don't need to fix it yet. Okay, let's do Jackie hair. So we need damaged. And so the way this is going to work is I think it's going to be sort of an outline where basically let or like uniform cut off. And then we need like our normals with the dot product of the world. So I think this will be like let's look at the bubble. Because it's basically going to be a variation of this. But basically, the character is going to be white for a frame, and then they're just going to turn, they're going to gradually fade back out. So we don't need a texture. We could do a color, though. So we'll do just albedo equals color.rgb. And then we'll actually do float z equals this. And then if if z less than cutoff, discard. So let's see what I can do. So we can have and then we're also going to have the cutoff go to like 2 or something. And admittedly, this isn't super efficient because I should just have the ability to disable the, well, and now it's not going to quite work. But it does kind of do what I want. Because basically I want the character to flash white and then fade out. Or maybe like red. So this is like the, you have been hit and are damaged now. And let's make this go back to 1. It'll be just like uniform int show 1. And we'll just, oh wait. Can we do like a bool? Are there booleans in? So yeah, now we can just do that. Admittedly, the better solution would be to just animate the actual overlay, I think, and just disable it completely, but this way... Admittedly, this isn't quite what I want. Because I think the cutoff should be, well... I guess this is fine, because what you would do is basically, it would turn on at 0, and then it would fade out, and then turn back to 0. And then maybe even animate the color, that'd be fancy. But okay, let's add an animation player here. Wrong animation player. So let's just add animation. And this will be like damage, anim. And by default, this material here, I guess it should probably be on Jackie, because other characters might have something else. But okay, let's key in that this is off by default. And we'll also key in the color and the cutoff. And then right here, that will be off. And this will be 1. So why also does the... I wish they were a bit more graceful. Let's go back to the shader. Because can I do, like, if it's 2 here... 1 minus normal z times color.a. So I think this should always be between 0 and 1. I guess I could just clamp it. And I don't need the alpha here. So we're going to do clamp 0, 1. It's weird that, like, millimeters from there. I guess I could do... trying to think what I want. I could do a dither. Like, it goes up to 1, and then it dithers away. Still strange to me that it wouldn't be discarded everywhere. Oh wait, less than or equal to cutoff. There we go. Well, it still doesn't quite look right, because it still has the graceless, it still has a not very graceful cutoff at the very end. I mean, admittedly, that's also just way too... It should be like 0.1 seconds at the full value. And then like it should be like this. In fact, and this should be probably more like this. Or maybe more like this. Because I should probably make this, like, the tail end of it faster to hide that poor quality thing. Well, it's a pretty neat effect, I think. And now I'm going to make it so that basically the player is invincible for the duration of this. So let's do like... We'll need now a proper like time damaged const time iframes equals 0.4. So now I think we need timer's max will be 3, and then const timer equals 4. So the damaged timer will not be affected by this, I think. Yeah, so we'll reset the state there. Because otherwise... Take damage. Do we have... We have this, okay. So we have this, and that, and then return after time iframes true, time damaged, no, timer damaged. This does technically mean that the player will not take damage for 0.4 seconds after getting hit right now. That's okay. Take, so let's do function take damage. And we'll do like mesh dot play damage and mesh. Oh no. We can just do it in here. And also let's do timers damaged. Maybe like after. Huh? 0 false. This resets the damaged timer. Okay, and now let's go to the animator. Let's do start damage particles. Oh. And this will be damage anim dot play damaged. So now there should be, now the player should flash red when they get hit, and that red will disappear to match the time that they're invincible. So they're going to be invincible for even longer than they lose control. Because that used to be, basically I set it up so that the player was in that damage state, they couldn't take damage again. And I thought that'd be good enough, but playing this little area with the steam especially, it just doesn't feel like it's enough. Okay, but now, weird. Oh, I think I see. Maybe. So that's a little more clear, but I think it could also be even clearer. Because let's do like, maybe it goes to a bright white here. So let's do like, duplicate key, make it super bright white. And also I want it to be like, maybe more like this. And also, I think it should be a little bit longer even. So, like, let's try 0.8 seconds. It's going to be very generous here. Let's try like this. And then let's go to time iframes. Because this does mean you get a pretty generous damage boost. And also, I might even do more dramatic stuff where I, like... Because I've also been thinking, currently the way stairs work in this game is I just have to make them ramps. I'd like to do a little bit more with them, though. Because, right, it feels sort of inauthentic to the rest of the game, where, like, I try to have, like, a very one-to-one relationship between the geometry and what you, like, interact with. Or what you see and what you interact with. Except for stairs, which are just perfectly smooth surfaces internally. Oh wait, the entire point of this is not to gamer it up. It is to... Weird. Okay. So I've, like, snuck my way onto this thing. Oh, I know why. It's because, how do I handle that? It should probably be that they damage the enemies every frame? Because, yeah, if we go to the, thing. Hurt box. Because it does an on-body entered. So we've actually entered the body, but we didn't take damage when we were there. So what I think we need to do is, how does take damage work? So if we don't take damage, or damage equals 0, return false. So I can just make it so that what they do is, while they have overlapping bodies, we can do, like, set. So, like, set physics process get overlapping bodies dot. We'll do, like, not. And then we'll do, I guess we don't need this. So we'll do active. Oh wait, no. We still need this. Set or active equals A. Set physics process. Let's do like so do and not get overlap bodies empty. And we have the exact same logic here where it just does update processing. And so function physics process for body and get overlapping bodies. So there should typically be only like one. I'm going to do like, and this does mean that enemies should probably have iframes as well, maybe. Because now they're going to take damage every single frame, so they'll get instantly killed by these things. Oh wait, and we should also have exited. And we'll do on bodies or on overlap change. Because we don't actually care what happens with this body. We're just gonna check, because we're just gonna recalculate if we have any overlapping bodies. Oh, there we go. Ouch. Well, I gamered it up. And I didn't even test the thing I was supposed to test. But honestly, I like how it looks, like that effect. It seems pretty clear that it's like, you have been hurt now. Now, next thing I need is a death animation, finally. But that'll be later. Because this was mostly because, you know, I still want also a louder sound for when the player gets damaged, but... Oh wait, hang on. My health isn't being reset when I respawn now. Yeah, I better double check this. Because I think what's happening is there's some sort of synchronous... Yeah, there's some sort of, like, sync bug with, that. I know what to do. Let's go to, timers. So we don't need... So we do need that to be there, so... Let's actually do respawn. And this will clear all of these stats. So we actually... So this way, we still won't take damage. Let's do this. Okay, so now, actually, hang on, I need to get on this thing. Well, there's some jank with the timing of this still. Like, it seems like I can still, like, get onto things and then they don't, like, activate. But maybe it's just I was so fast and such a gamer. Okay, so that solves that issue, because now there's just a little, or almost a second after you respawn where you don't take damage, so anything that damages you the frame after you die, where you're still technically in like a hurt zone, is fine. But this... So why am I, like, not here? So I think this is here. Okay. Oh. Okay, so we need to be in the hurt box. So it's not working. I guess let's set active. Oh, wait. I forgot to put this back. Alright, that was why I refactored that. Okay, so now if I'm standing here... There we go. Oh, it took a little bit for it to register that it was supposed to get... Okay, there we go. So now it's much more generous. Look at that, that's how video games are done. So hopefully the player will even be able to play the video game like that. Okay, so I'm gonna say the iframe stuff looks pretty good. I like how that turned out. I think that's a neat effect visually, and I think it just makes the game a little bit less unreasonable with damage. Actually, let's actually commit stuff one at a time instead of what I usually do, where I just commit everything at the end. Someday I should figure out how to monitor like disk usage to figure out what is even like causing the external drive to spin up when I like do Git. But oh well. Oh yeah, and I figured out one of the things that's causing performance hitches is my little fancy UI bar will sometimes just take like 40 milliseconds, which is just not acceptable. So I'll have to figure that out eventually. Alright, what are the other changes? Are these? Oh, right, because I pushed the thing around. I didn't finish that change even. So let's do better iframe, or more iframes, and a visual damage indicator. Okay. So let's go back to here, because we need a reset animation as well. Is this correct? Oh, right, and this thing should probably be... Let's rotate this a little bit differently. So, because this thing is supposed to be... I think it should be a little bit further this way. Let's keep that in here. Was that there before? I guess I'll keep that in reset tracks. Okay, so now when you get shooped, it'll probably be about here, which, well, not the best spot. Let's see, do I have... Oh, my playlist just isn't... It just didn't continue the playlist. I'll say that's good for now. Let's go back to reset. Oh, I see. It's because my refresh function doesn't... right, I have to reset the, or reload the area. So let's put this here. And let's just copy all the attributes from these, I guess. Because, I mean, admittedly, I don't need it that much because none of these are, like, relative to anything. Maybe I'll just keep these for now.
The problem is, you see, we haven't been taught to feel that way. The myths underlying our culture and underlying our common sense have not taught us.
Okay, so how does this look?
But only parts of it, only in it, only confronting.
So yeah, now... Okay, that seems a bit more generous, because that gives the player more time to get across this thing before they get blasted. Okay, let's do this from the top. And by the top, I mean the start of this half of the room. And then I should add the way back up, or the way further up to the back of... You know what I mean. The final third of this area. Well, I almost made it. Sometimes I just get my ledge grab eaten there. Or I just failed a ledge grab.
On other galaxies, maybe they'll find a better game.
Well, I could still make it through, sort of. What exactly am I missing? I think it's just the ledge grab. Yeah. Okay. Let's fix that now, because that's the thing that's now being like the barrier to this being a good area. Is the fact that the ledge grab or the ledge jump simply doesn't function correctly when we're on a moving platform. So let's go to a little test area. Wrong thing. Test world. So let's get rid of a bunch of crap in here. Whoa. Game not functioning. Oh, right, and we don't even need ammo anymore. Yeah, next on the chopping block is just that ammo. So I think these run on a loop. Yeah. Yeah, so like... okay. So if I hold forward into it while I ledge jump, I sometimes like catch onto it so that way it registers that like I'm touching it and it gives me that momentum. But if I just press A here, so if it's going up... Yeah. How do I fix that? Because that means that I need to be able to know when I have floor velocity. And the way the physics is set up internally, that's not really a thing that I'm given access to. Because basically what we're looking at now is Godot's built-in physics, like kinematic body. I really hope I don't have to make my own kinematic body. Let's see. So we need to open a recent folder. And it's going to be in the 3D physics body. Because we're going to do move and slide internal. So where is floor velocity decided? Well, I guess that's Okay, so was on floor and psnap and not on floor. Okay, so we only get the floor velocity. This is exactly what I was remembering. Basically, we get floor velocity only the frame after we've no, only after we're off the floor. Otherwise, it just applies it directly. So because we can look into here, it does current floor velocity. Let's see, where does it add the velocity here? Well, this sets the current floor velocity. So then if we're on the floor and we have current floor velocity, it'll add that velocity to our stuff. And because we're ledge grabbing, we're not on the floor. I have to manually track that. Which I guess... I know how to do that. But then I'll have to figure out... Okay, first let's go to the player, ledge, hang. Where do I get the, like, movement of the player? Right. So it's basically the exact same stuff that this does, where we just move and collide current floor velocity times delta. I just directly grab the amount of movement from the last frame. So what we can do is we can get a floor velocity from here. And I'll track that actually somewhere. So it'll be like applied ground velocity. Do I use that in ledge jump? Okay, I think what I'm going to try to do is I'm going to try to use the this movement here. So new position, old position. So let's do like var frame velocity equals new minus old divided by delta. And then applied ground velocity equals applied, let's do like a lerp. Frame velocity. And we'll just do like an exponential fall off basically. Oh. Oh wait, we need not origin. I think. Yeah. No wait. do we? No, we don't. And then when we do a ledge jump, velocity. So let's do applied ground velocity, and applied ground velocity equals 0. I think this might work, maybe. But I think there's going to be knock-on effects where it has bugs with other things. Because I don't really use the applied ground velocity in many places. Okay, so we can see it kind of works. Because we can see now that when I like grab onto things, but it's exactly what I feared in terms of like if we're moving forward, where if I move forward now, I shoot up like a rocket. Though admittedly, it seems like there's something busted with like walking on the ledge here anyway. And giving the player too much height when they ledge jump up a moving platform is not an improvement, really. Because I was also having issues where, you know, I was getting shot up 1,000,000 feet, but then I couldn't time things properly because I was too far in the air. Yeah, this at least seems to... Let's make a separate variable, though. So let's do, like, var ledge velocity. So this way, we're tracking that specifically for that. And someday soon, I would want to remake, or I want to like, well, do I want to do a refactor of this? I guess it's still one of those things where it has to be after the main content of the game. Oh, I guess I can just test it in here. If I can learn how to, okay, so moment of truth. Okay, this seems promising, kind of. Oh, no, I saw like a weird thing there. Where like I hit my head on the ceiling of that moving platform and then I like shot 1,000,000 miles and I was too quick to reset there. Okay, and jumping on horizontally moving platforms also sucks. Oh wait, that's what I should be testing still. Okay, so there's some bugged stuff with the movement still. Yeah. Now when it's moving down, I can't jump up. But I can kind of do it. Okay, so if we're moving like backward. Okay, so it applies too much velocity and it sends me backwards. Hang on, let's also do like move and slide. So we don't need this. We need this. So this is the ground when the player is attached to something. So I'll do that maybe. Because basically I think it's that I'm bumping my head on the ceiling of things, and it registers that as being on the ground. So I need to... ooh. Did you see that lovely little bit of jank? Yeah, now when it's going down, I can't get... Yeah, so it's sort of the opposite problem. I'm applying too much velocity. But that seems like something that could very well be frame rate dependent now. Oh, geez. So we can see that, yeah, as it's moving down, I have significantly less jump height, and also... So how do we fix this? I think I need to figure out... What do I need to figure out? I think I might have to actually change the kinematic body's behavior now. Because there are various things that I think aren't working. So let's have blue be the player and black be platforms. So in the basic case, let's say the player is on a platform and it's moving, and they're moving as well. So the platform has moved some amount of movement p, and the player, relative to the platform, has done some amount of movement also p, because player and platform have the same thing. But let's say this is going to be J for Jackie. So now, when the player moves, it's just J plus P, which is good. That makes sense. When the player jumps, though, we need to convert. So this is the actual like distance that the player is moving in a frame. Okay, and P is actually the distance from the centers, but it's that much. So this platform has actually moved quite a bit. But
when you love someone, you love them through all their moods and changes.
so this is basically the move and slide for the player's velocity, and a move and collide for the actual distance the platform has moved. And then we don't need to bother tracking the... well, I guess we do need to bother tracking the platform velocity. And then let's say, like, if the player is on it and then they jump off, we need to apply the velocity. So they're here, and now they're here. So now we need this as, like, VP. And VJ. Because basically, I guess this is all still exactly what the kinematic body does in Godot's code. Basically, if you're on the ground, it just moves you by the amount. And if you were on the ground and now you're off the ground, it adds that velocity to your thing. So this here, velocity is VP plus VJ. And then VJ is subjected to, or VP is just put into your velocity, and then you can do whatever physics you want to do with it. So this is all good so far. However, where we differ is where the player is grabbing a ledge. They may or may not be actually touching it. And let's actually do it from the center now. Like this. So we have here E. And then if you jump while this is moving, we need... What do we need? I guess we still need VP. And so how do we get this to be treated as if we were on the ground? Because right now the problem is, if I do it in code like I'm doing now, we sometimes get situations where you are ledge grabbing, so it adds the velocity, or it adds this position, and you're actually touching the ground, so it adds this. And then there's the other complication, which is that sometimes you are actually climbing a surface that is moving. So if we have like this, and it can also be an overhang, so it could be anything like this. If this thing moves, and the player's climbing it, we still need to do E plus J. And if you ledge jump, you need to do VP plus VJ. So basically, I think what I need to do is I need to have an ability to explicitly mark certain surfaces as being the ground, regardless of whether or not they're actually the ground itself. Like, I need to just be able to set it from outside rather than... Because basically... So if we go back to our code, or if we go back to Godot's code, is on floor. So on floor. We have... Yeah, basically... all of this stuff of the on-floor logic, we need to throw it out. Or we need to not have it done in Godot. We need to manually set it, and then do all of this same logic. So I guess what I could do is I could just make it so that we never have this up angle. Or like so that p-floor max angle is something that's impossible to get. And then I can manually apply that velocity, because I already have to detect if we're on the floor. So like if, because I already have this. So I think what I need to do... Yeah, I think I just need to make it so that we don't have the floor. Or we just don't do this floor logic. And I do the floor logic. And I could change the source code, but I'll just not do it for now. Maybe eventually I'll like port my logic into here, and then basically the kinematic body would have functions for like set floor, clear floor, stuff like that. Well, nah, I won't do C++ today. So I need to think about what we want for this. So I think it's going to be like if state.sticky. Or if like if stick to surface. Let's set this as Python syntax to mock it up. Because basically my code is already kind of confusing for when the floor is like doing stuff. So this may actually be the time where I need to do that movement refactor. But for now, let's do like a best floor equals get. And let's just do it like this. So like, how would we do this? State ground. I'm gonna think on this, but I need to take a few minutes to break. Oh, wrong BRB screen. That's my coding one. Okay, I'll be back in a couple minutes. I'm gonna think on this. Okay. So we have a few things that we need to think about. When the player is touching the floor, so let's grab this. So let's use the player as a demo, or as a little doll to demonstrate this with. So like, let's say the player is ledge grabbing. You know, they're gaming. They're here. And then this moves up a little bit. Or, yeah, it moves up a little bit. So the player is moved up to match. And that velocity is tracked somewhere. So that way, if the next frame they jump, and then they ledge jump off, they get that extra velocity so that they can clear this. And the trouble rises when, let's say, they jump off, and then they hit this again. So now they're on the, technically like touching the ground. So this goes up. They're moved up to continue going with it, but then they, you know, come off the ground again because they're going over this ledge. And now that velocity has been applied twice because, you know, they got the extra speed when they ledge jumped and they got the extra speed when they hit this and then came off of it. So then they go flying and it's way too far and they can't time things. So what we need is not to do what Godot is currently doing, which is basically it just sets your velocity, it just adds that velocity to your thing. You know, because it does body velocity plus current floor velocity, and then it sets your current floor velocity to 0. Wherever it does that. Somewhere in here it sets floor velocity to 0 once it's been applied. Oh wait, yeah. Actually, is that what this does? Current floor velocity equals current floor velocity slide up direction. Nothing there. Current floor velocity. Body is removed or destroyed. Oh, okay. So this is if the body is invalidated. Oh, wait. Yeah. Yeah, so it's exactly what I was talking about, I think. Strange. But yeah, basically, I need to have this floor velocity exposed at all times. And I need to be able to set it I need to be able to set the body that's being tracked manually. Because the ledge grab and the ground should both be communicating with each other. That, like, you have some velocity from the ground already. So once, you know, so when the platform moves up a little bit, and you're moved up with it, it doesn't double the velocity, it just adds a little bit more to, like, help you keep up with the ground. And then you can stand here and then it moves around and then you're all epic. So I think what that means is I need to not use is on ground anywhere in our collision. And I guess this makes sense anyway. Oh, and we also need this for, what you call it? The sliding. So let's try best floor. Don't I have like best wall and stuff? All right, let's go back up to here. I really should make these, I really should refactor this to be not like 1,000 million field enum with 250 lines of just declarations of constants. Like, it's line 386 where we get to the first function here. But okay. So I think we also don't need the floor is stable. We eventually won't need it, but I'll leave that as it is. So movement input get vector. So let's go through our ground. So when we're doing this, I guess this is fine, because basically we're just getting the highest normal, which is always true. Even for things like climbing, we want to get the best possible surface contact point for the ground, because that means because this is where the stamina is drained the least, as opposed to like if you're also touching the ground here, or like a surface. So best floor looks correct. Best dot looks correct as well. And it also gets our depth, so that way you can get crushed to death. Then ground index. Oh yeah, and this is just the ground index. Basically, this is to average out the normal over the course of, or over the previous 4 frames. Then that. So best floor dot equals the maximum of the average normal and the current normal. That makes sense. Current normal Y, ground normal this, ground normal that. That seems okay. We don't need to worry about water. Oh wait, I guess... Oh, this is just the debug stuff. Okay. So I think all of this stuff is good. We need to look at where move and slide are done. So yeah, this first match state, that's fine. Let's see, is on floor. Applied. So I think... I don't think this does anything. Like, I need to be really clear about trying to understand this. Because, like, because floor velocity seems like it's always reset. Like, do we actually do anything here once we, like, check it again? So floor velocity equals collider.this. But this is only if was on floor, and snap is not equal to an empty vector 3, and we're not on the floor. See, I'm almost certain this is never true. But let's see. So I think I can just view it in the stats. Okay, so one of these is the applied floor velocity. GV, okay. So it makes sense right now to have no ground velocity. Okay, and here... Okay, so the ground velocity actually does apply for that? Huh, okay. I misunderstood that. So we do actually have the ground velocity here. And then if I ledge grab here, there we see the issue. Because this is the applied ground velocity, and we're not actually getting any floor velocity from this. So yeah, let's get applied ground velocity recalculated. So this is no longer going to be floor velocity here. So what is AV then? Oh, I understand now. Okay. So if we're on the floor, so this is actually going to be if, like, best floor. So basically, if we are colliding with a surface, we don't need to deal with this AV stuff. I guess. Now, what do we need to do? What is the simplest case that I need to support? Let's start simple. When we do move, so the collide should not be doing this. What we should do is like a move grounded, and then it should be like, what should it be? Let's do like var ground node. Var ground velocity. Vector 3. It's like function. So like match state. So we have a few states that I'll do. State.climb, state.fall, state.ledge hang. So I think it would be like ground equals get from ground from collision. State ledge hang would be like ground get ground from raycast. So this is sort of not, this isn't really in the order that it would be in. Ground well equals and then here we would do the same thing as this one. State fall, we would do like ground vel. So like ground equals null. Ground velocity equals like some drag or something. So basically we need to calculate the ground as a function of state, because for a ledge hang, we always treat the ground as the surface that we like ledge hanged onto. And then we just apply the velocity of it onto us, no matter what. But for ground and most other states, we actually get the ground from the collision. So like, and we actually get the ground as a condition for doing state. So I guess that would be how would we do this? So if I were to do this all again, there would be like input get player input or whatever. And then var so like I wish Godot 3 had lambda functions in its GD script, because that would make this so much more convenient. Because I had a system in Godot 4 where I used lambdas that was very effective for this sort of state. Because I want to have the ability to just add the logic to each individual state for these sorts of things. Because with classes, this is going to take so much boilerplate. Okay, but I guess I still don't really understand the fundamental logic of what I want here. So let's just do move and slide. So we need this to be like negative... Oh, wait, no. This here, negative infinity. So we're not going to do any sort of movement. Actually, let's do like move grounded. Let's just have this. So velocity equals move and slide with snap. And it'll be almost the same thing as this, except instead of doing min.ground, it'll just be nothing, because we're never going to be doing this. And then we actually need the ground as well. So let's do like... Let's pass in the ground manually. This will be like... Oh. Well, then just make this a spatial. Because it should be anyway. Okay, and then we're going to do what we do for the ledge hang. Which is we're going to do all this stuff. And we're just going to do move grounded vector 3 0 ledge. And like ledge last transform. Yeah, that's fine. Ground and then ground last transform equals floor last. And we'll have to have that as well. So for our last ground origin equals let's remove this. So if ground not equal to floor or ground last transform, ground last transform times that, new position equals should this all be passed in through this? This seems like it's too much bookkeeping. Because this means I have to have two separate variables for all this stuff. Let's just assume the ledge will do its own thing. Or the ledge hang will do its own thing. So let's do just like last ground origin equals global transform.origin. Where do we use this? I don't think we use this anywhere. For now, at least. Oh wait, no, we do use this, actually. Because it's going to be, we're tracking the origin of the ground. I guess? Wait, but we don't need that. Okay, so if the global transform of the ground is not equal to the last transform of the ground, and also we are checking the ground, like if the ground exists. Let's do it is instance valid. So if there's a valid ground, and the ground has moved, we get the new transform, we get the old transform of our local ground. So this is like and then our frame velocity is the new position minus old position divided by delta. So that's good. And then we move and collide. And then last ground, last transform equals new transform. And this is going to be now ground velocity. So we're no longer going to have applied ground velocity, and we're no longer going to have ledge velocity. We're only going to have ground velocity, and we're going to have last ground transform. And we're going to have I'll figure that out, all that other stuff out later. Did not lie. I'll ignore this. And I'll ignore this. Okay, so here... There, everywhere. Roll doesn't need this. So yeah, most of these are no longer going to track this because we're just going to do a move grounded. And I guess what we'll do is we'll just set the ground velocity stuff here. Alright, so can this just show me like all the errors at once? Or is it just going to show me them one at a time very, very slowly? Okay, best floor. Best floor is now just ground. Ledge last transform is now just ground last transform. And this is ground local position. And this is ground. Okay, so we need to actually have a few things. Let's go through from top to bottom and try to figure out what I need for things like the ground movement to work. Well... Oh wait, that didn't, whole word match case. And now, not whole words. Where we did that. Whoops. Gonna be a lot of this, I think. Oh, wait. Okay, that's good. Wait. Yep. Okay. How is delta not declared? Oh, right. Because we need the delta. Oh wait, we already do ground equals null. What, didn't I set? Oh wait, no. Okay. Maybe I should try to refactor some of this stuff while we're here, like more thoroughly. Because, okay, we don't need the ready, we don't need the input, we don't need this. Our first thing is, when do we get the properties of the ground? Because we want this to be handled exactly the same for when the player is either, you know, ledge grabbing onto this surface. So this surface is the ground. Let's do like this. So I guess what we do is we don't actually set the floor until we have it here. So like, let's do var best floor equals null. So we're gonna still have a best floor. And this will be used for our logic of like, you know, because when you're ledge grabbing, if the floor comes up under you, you drop off the ledge onto the floor. So let's do like... I wish there was destructuring, or like tuples, because I've gotten so used to JavaScript now. Which is like, I mean, there's a lot of problems with JavaScript, but there are some nice things nowadays. So maybe I should learn like a really nice... I guess I could learn a really nice like dynamically typed language, or just some language that has just a nice convenience features that modern languages have. Because GDScript, especially this version, is just kind of bad. I mean, it's well integrated with the engine, but there's just so many modern features in languages that are just so useful. Like having typed enums, for example, since I can't do this. I have to just type it as an int. And we got our water stuff. I think I know what I need to do. I think we need to have our best floor, best dot stuff not happen in here. We need to have it happen the previous frame, right after we move, I think. Well, no, we don't need to do that. This is still good. This is still correct with the best dot and stuff. Let's go through this stuff. Wait, there's like a mix of logic in here that I kind of don't like. Yeah, because we're sort of doing stuff like this, when this should be a function that just determines when the next state is. Oh well, let's continue on with our journey. Oh wait, whoops. That's what I get for doing so much ledge, or like name replace. Hmm. And all this state logic. Needs our... Let's rename ground dot, because I think this should actually be best floor dot. Okay, yeah. Wait. Yeah, that should be fine. Best floor and that. Okay, so where is ledge grab as well? Or ledge hang? Yeah, best floor dot. So basically here, it doesn't even check for the best floor, it just checks for our state. So we don't need... Well... How do we apply the state? So if... So if state is not equal to state dot ledge hang, then if ground not equal to best floor, our AV will equal 0, or well, I guess this is fine actually, because this is 0 by default. If the ground is not equal to the best 0, ground velocity equals vector 3 0 best... Oh wait, no, let's do like if best floor and that ground equals best floor. If this else okay, so is this correct? Alright, we also need AV to equal ground velocity. That seems correct. Because basically what this means is when we're off the ground, our applied velocity slowly drains away. Otherwise, well, do I even need this applied velocity? I don't think I do. I think I can just do ground velocity equals blah blah blah. Because basically what this means is if we're no longer on the ground and then we land on the ground, our ground velocity is set to 0, so that way we're ready to just like get ground velocity from the ground again. And then let's replace this with nothing. I'll figure that out later. So our state is state ledge hang. Okay, and we set the ground at the best floor. Oh wait, what we should do also, we should probably have this no matter what. Yeah, we should have this regardless of all this stuff. Because basically we just reset the ground velocity or we drain the ground velocity, and then we assign the best floor to the ground no matter what. So this seems correct-ish. We'll need to make sure that we get the ground velocity appropriately. But then let's get this first. So eventually, let's get applied ground and remove that. All right, let's go through each and every line of this code and let's refactor this to remove applied ground. Because eventually I think this will be just ground velocity. Okay, so I think that was all we needed. And let's do that. Velocity equals move toward ground velocity. I see what we can do. We're not going to set the ground equals best floor. This is not going to be quite what we do. We're just going to set it here, and then elif empty ground area, then the ground will equal null. Oh wait. This is not actually correct. We don't do this here. Oh, I understand how this is done now. Okay. That'll be for later. Because what I wanted actually, times equal, let's do like minus equals velocity times like 0.01 or something. Like some sort of drag factor. Maybe something like that for now. Is this right? I guess that's right. So yeah, basically, That all seems good. That's how we set the ground. Otherwise, yeah, otherwise that's all good. Oh. Wait, actually, we should probably get the ground here as well from... There's so many moving parts to this, literally. I think I might need to do like a greenfield test to figure out... Yeah, you know what? I think I need to go completely greenfield with like just a simple little test area. So let's do like a CSG box for starters. So this will be like a... shape, box shape, and then mesh instance cube mesh, and then we need a little camera. And then we should duplicate this with like make unique. Make unique. And this will have animation attached to it, and this will be like loop. And it'll just go like, let's say it starts here, it down, stays there for a second, and then it comes up. It'd be more like this. It's weird that it like jumps down for a little bit. There we go. There's something weird. All right, and this will be an auto start animation. And so now this will be areas test green field. I think that's, neither one looks right. But okay, so we have a little void of nothingness. And what I'm going to do is I'm going to add here test kinematic body. So like function, or let's do function const speed equals 7. Let's do, let's do like a var velocity equals vector 3, 0. So like while we are going up, if or like var input equals input dot get vector move left, move right. So is this, yeah, and then we'll do X. So it'll just be like, so for now, what we're gonna do is hvel equals velocity. Hvel dot y equals 0, and then hvel equals move toward from this to input times speed. No, so I think left is this. No. And then L dot y equals velocity. L plus, and then like velocity equals move and collide. Or let's do like a move and slide. From our linear velocity, which will be hvel plus gravity times delta. And our up will be nothing. So maybe that is what we need? Okay. Too few arguments for get vector. Expected at least 4. Oh wait, let's do get axis. Oh, right, and we need a speed, so it'll be like Excel. How does this work? Because I think we can do... Oh, I thought we could do vectors. Don't I do that? Move toward... Oh, I do... Okay. I do hvel dot move toward. Hvel dot y equals velocity dot y. And then velocity equals move inside hvel, x plus gravity or whatever. Okay. Let's see if this does what I want it to do. So basically, I should have the ability, I do. So I can move, and I can't really do anything. But it's fine. And then I can have, like... Let's also have a button like if... Put dot... Wait, let's do... So we want to determine if we are on the ground, I guess, is my first thing. Because now we have the ability to move. And that's nothing fancy yet. So let's do like var ground, spatial, var ground velocity 0. So let's try having like a function grounded move for the velocity. Wait, we know what the velocity is. Oh wait, no we don't. Alright, so let's do like update ground. So like for C in get slide count, let or collision equals get slide collision C. Or best floor equals nothing, or best dot equals negative infinity, or let's do like best normal. If collision... Oh wait. There we go. So normal is greater than best normal. Best floor equals collision dot collider. Best normal equals dot normal. And then ground, no, so if best floor and ground not equal to best floor, ground velocity equals nothing, otherwise ground equals best floor, and our ground normal. Ground normal equals best. Okay. So let's do like if grounded move, else air move. So this will be almost the same for now. But now we're going to have our ground last position. Or ground, or like last local transform. And var ground last transform. I guess we just need this. And I guess for now, let's do like, so for grounded, if input dot is action just pressed move jump, then hvel.y equals jump velocity. Let's do const jump velocity equals like 5. Okay, so seeing this in action, what we have, oh, not quite. What we have should be a little thing, a little box jump up. Can't quite make that jump, so we can do like... And now, we can see the same problem in the base game that I was talking about. So let's solve that by calculating from our grounded movement our ground velocity. So what it'll be is plus ground velocity. So h velocity equals, what is it equal? I guess it'd be... So yeah, we set our h, we set the y, and we set the ground velocity. And now what we do is we go back to the player, go to move grounded, get all this crap. And then we add this first. So basically, if ground last transform, okay, here's our ground local position as well. So if ground are then our local position equals global transform, no, ground dot global transform dot affine inverse times our global transform. So this basically gets our transform relative to the ground. So transform and transform on operator blah. Oh, and we just need the, oh wait, okay. We need global transform dot origin. And let's make this less confusing by just calling this our ground local origin. Okay, so let's see if this does what I think it should do. So it shouldn't mess up our velocities or anything. It does mess up our velocities a little bit. Is that because this is not synced to physics? New position minus old position. Nope. Not quite. So let's do now and ground normal dot y greater than like 0.5 or like 0.8 or something. So this is sort of replicating the logic that we already have for grounded movement. All right, fascinating. So our p velocity plus gravity times delta, and we don't use the ground velocity anywhere here. Oh wait, I see. Let's do if or like else air move h vel delta. And let's try to make this, so I'm going to try to clean up this code as best as I can, but basically, and this still doesn't, yeah, that I don't know what that is. Oh, I do know what it is. It's because when we update the ground, are we checking to make sure if best floor and ground is not equal to best floor, ground velocity equals vector 3, 0. Ground equals best floor, ground normal equals best normal. I know. I think this needs to be the case no matter what. Because if we jump off the ground, we're already applying our ground velocity. Oh, wait, and also, our last... So, ground equals best floor. If the ground last transform equals local ground.transform and local, wait, we don't need to track this ground local origin, do we? Okay, we do that every time. So we always recalculate this variable. In fact, do we need it here even? Because we can just do if, because we're already checking to update the ground. So we can just do ground local origin equals all this stuff. And this will be global transform. So it's basically because we are moving from X to Y. Okay, and now we still don't really get our ground velocity, so let's add some UI here. So we want some sort of tracker. Don't I have things that automatically track? Let's create a new script called like debug. So we'll be in tools, scripts, like property debug. Create, and it'll have like an export node path var node export node path var property. Or no, this will just be a string. Export that'll be fine. So like var prop equals get node var property, no, var val equals n dot get property, and then text equals so it'll be property val. And then we can add this property debug to these, so it'll be like assign so which one of these? So this is player. So we're going to debug the player for each of these. So we're going to have like the ground velocity, the ground name, I think that's how you do nested properties, and then ground, no, just velocity. So I think if I've played my cards right, we should have 3 little signals up here. Ground name is null. So we're not quite getting what I want. And I know why. That's because we need to have an area here. So now we're getting into the things that we're already doing for this. So let's do this. And this will only collide with mask 1. You have a shape. It'll be a box shape. And this will be our ground area. And what we'll do is, if the ground is the same as the ground here, so like if not best floor, for G in ground area dot get overlapping bodies, if equals let's do like best floor equals G, and if G equals ground break. So basically it'll get whatever floor that we can get here, and if we can't get a floor we'll break, and then we'll do best normal equals vector 3.0, or no, best normal equals ground normal. So basically it'll preserve whatever state we were in if we are still overlapping with the floor, and it'll keep our velocity unless we actually, you know, have fallen off the floor. Okay. So that might help with the ground then. Not quite. So also I need to figure out how to get, so can we get a property? How does the property bar work? It's almost exactly the same thing, which I figured. But okay, so we need to get. Note in C# the property name must be specified. Yeah. Get class. How does the animation player do it? No, how does the tween do it? Let's go do that. So animation tween should be somewhere in here. Tween property. Interpolate property. How does this work? So we have a node path to the property itself. And pending command p property. Get as property path. So I think we can actually do like a node path instead here of like. Okay. So this is passes a node path to the X property in the position node. This will be parsed as the node path to the X component of the position property. Okay, so that's exactly what I wanted. So I think, do we have, so we still don't have a ground, and we still don't have ground. Oh, these aren't working anymore. Then how do we do this? Print property path, get as node property, property path. Get property. So how does this work exactly? Hmm. Hang on, let's go back to here. So if we have a property, and do we return early anywhere? No. Because we should still be getting ground last transform. So now we're getting a ground velocity. And look at that. Now it applies, it follows the ground appropriately. Mostly, almost. There's still a smidge of out of syncness, but that's because I can have the motion here sync to physics. And then we should also be able to jump. And it almost works. Ah, but I see what we need to do. We need to also set the ground last transform here, maybe? So if ground is not equal to best floor, if we have ground last transform equals this. Oh, wait. Wait, no. There we go. Okay, so now I think when the player is jumping up a platform, or when the player is jumping on a moving platform that's going down, I think we actually want to cheat a little bit, because I think the player's in the air for the same amount of time, because their velocity is relative to the ground, but it doesn't feel right. It feels too slow. So like, whoop, whoop. No, I think they're falling faster than they're supposed to be, actually, looking at this. If this were, like, at all reasonable, then we could do that. Let's do like so in property debug. String, so like prop val. So let's do function string prop val. If val is vector 3, return percent like 5f. Let's do like 5.2 or something. I can't quite tell if our velocity is correct. So it goes up to negative 6.74 or 6.74. And then when we jump, it goes up to like 14. So then, let's get our max velocity. Or let's log. I know. Dot log, jump. No, not console.log. Print hvel, and then ground velocity. So that's going up, and that's going down. Okay, so this clearly... Well, no, I guess it's not wrong. Let's do hvel minus ground velocity. Okay, So my intuition was, or my assumption was correct. It's physically accurate. The velocities are correct. But at least in this frame of reference where we're looking at the room as a whole, it just feels wrong. Because, like, we jump, and then we jump. And it just feels weaker as we go down. But that's okay. But now what I want is the ability to add a ledge grab to this simple little example. So let's start creating states here. So I think what we want is to create states as functions, or like let's do like var ground equals is this how we do objects in Godot again? Oh well. So like move will be like grounded move. Var air. Move. Air. Move. Oh, right. This will be a mess. Let's do like var state equals ground. And eventually I would love for these to be out of here. But they won't be for now. So let's do state, or let's do like call state dot move with hvel delta. And we'll do something with that. Call state dot update ground delta. And let's do the same hacky stuff that I did for my other thing. So default state. So like update ground will be update ground. Well, I guess it's no, I guess that's fine. We don't need that. We'll do this stuff still. So like, let's have like the apply floor velocity stuff. Maybe, ugh. I still need to figure out how to get the ground velocity stuff, but let's add a simple raycast to this thing. So this won't be a good, because I'm not re-implementing the raycast or the actual logic for ledge grabbing, so I just need a basic thing here. So this will be just a ledge cast. And it'll be like, I'll leave that be for now. Next will be, can classes refer to the outer scope in this? Because I would love... I won't deal with it. Honestly, I think the enum solution is still the best. At least for now. So let's just do enum state ground air ledge ledge jump. If match state ground grounded move. Or so this will be like, let's separate this into a function. So like act on state. Let's do like well, what do I want to do here? I think act on state will have input delta. And then we can do like a state dot air, or let's do like get next state delta, and then act on state with the delta. All right, and we currently don't need that. So let's do like if ground, or so if not ground, or ground dot normal dot y is less than 0.2, or like 5, state equals state dot air, state dot ledge. Actually, so let's do like this. And so we don't need that anymore. State dot air, state dot jump. Oh wait, we don't have a. And I think here we can just actually return. And if we make it all the way to the ground, we return state. So we'll just do state equals get next state. State dot air if ground and ground dot normal dot y is greater than or equal to 0.8. Return state dot ground. The identifier h fell. Oh, right. Because we actually need... I know. And then for this one, we'll only have like return state dot air, so it'll only do it for one frame. So let's do... What do we do? Var state timer equals 0.0. And state equals next state. And then we act on our state. Okay. So we're getting closer. So like if input.is action just pressed, move, jump. Here we return state.ledge jump. And then maybe like ledge fall. I'll deal with that later. Or like we do like set state. No, we can't do that. Okay, states dot jump. So this is where we do our movement. And then we don't need this here because we just have this set the velocity it's directly. And that should be good there. And maybe this should not be in here. So we can just do, like we don't need to update the ground here. We can update it in these two states. Because here, we're going to update the ground with something else. Which will be almost the same. Except instead of doing our velocities there, yeah, that all seems good. All right, so we also need state.ledge jump. If state timer greater than 0.7, return state.air. If ground and ground normal, and we can also do this. Well, this one we just go into the air the next frame, so that's fine. Okay, so what we're going to do here is if ledge cast.is colliding, return ledge. Okay, so this is the actual logic that is going to be for this little test ledge jump. And And also, I've been so laser focused on this that I didn't even check the chat. But okay. So when we set state.ledge, and also we're just going to do state.jump, state.ledge jump. Those are going to do that. And then here, ground equals ledge cast.get collider. And actually, we should have probably like a set ground function. Because we have our proper like update ground. So this will do set ground best floor. Function set ground best floor. And I think we also need our best normal here. So this will be like spatial. Oh wait, no, and this is vector 3. And then here, we can do like var cast equals that, cast.get collider, and cast.get normal. There we go. Okay. So we have ground equals best that, this, that, the other. Oh. Index normal on base CSG box. Oh. Okay, so I should be able to just get this. Okay. So now I'm getting my little ledge grab. And it's not moving because we don't have anything in act on state. So what we should do is state.ledge grab. Or no. State.ledge grounded move hvel dot no vector 3 0 delta. So we'll stay in the same position relative to the ground. It almost kind of works. So what is our ground velocity here? So I'm seeing it's not 0 when the ground has stopped moving, which is weird. I don't know if maybe I'm just... Yeah, there's something off with that. Let's go back to our thing. And let's print the velocities still. Grounded move, air move, set ground, update ground, act on state, set state, print velocity, ground velocity. Oh wait, 0, there we go. Aha, okay. So yeah, my ground velocity is not... Oh wait, I know why. It's because we actually need to do this all the time. So else ground velocity equals 0. And also, well, I guess all the other stuff there is fine. Because we don't need to do all the move transforms and stuff like that. We can just set the velocity to 0, and then it won't be applied improperly. So now if I jump onto a moving platform, there's a little bit of jank with it, because we're actually, like, going down. But okay. The other issue is when it's moving, or there are just times where we don't move properly, but that doesn't seem to be related to the velocity. That seems to be related to the way that I've set up, probably like my ledge grab, maybe? Like, does my state timer set things to 0 at the correct time? So we do that, and that's correct. Let's get the state of the, let's get the state name. So we'll do like, just have a second property here. Var state name equals nothing. And then, state name. No, act. No, what am I doing? Set state. Yeah. Here. You do state.name equals state.keys state. And then I can just add another one of these. And we can do state name here. Oh, wait. Okay, so now we'll also be able to see if, for example, the ledge jump is maybe busted. Yeah, because it's supposed to be pretty quick, or it's not supposed to be that quick. Let's do like if state timer greater than 0.1 and ground normal blah blah. Oh wait, and we don't have the state normal actually ever update, I don't think. So like physics process should do state timer plus equals delta. And then we have delta here. Delta there. Oh, wait. I accidentally went to the actual real game world. We are not going to be in there for a while, I don't think. Okay, does this... No, it seems like it's still wrong. So we're at ledge, ledge jump, air. So where is it printing to? So let's do, when we set state, oh wait, we're in the wrong world. So we should log the state name. And also we should get some more music in here. Oh, it just, you know, YouTube just being YouTube. Ugh. Okay, so we went from ledge jump to ground to air to ledge. I think for simplicity's sake, I can do, what can I do? I guess I can just make it ever so slightly smaller. Because right now, the way that this ground works is, it's not quite the same as my other ground, or in the real game, because it's a box. So that means that even if it's perfectly flush against the ground. There we go. This means that it's susceptible to the donut problem, but that's okay. So is Jackie in the real game. So there is some jank with like getting onto a thing. Yeah, there's something wrong still. Yeah, because there's that... Yeah, that is fucked up. There we go. So I don't really understand what that means. So that is going from ledge to ledge jump to ground to air to ground. So what if we just have state timer greater than 0.7? So let's do like this in here. So it'll be like if this else. So like if we are in the ground after the 0.7 seconds of the full length of the ledge jump. And so this is, ooh, yeah. So we can see some things happening with the air. And that must be because the ground is... What is the ground doing, actually? Yeah, because we can see, like... Oh, wait, is the ground... Oh, I just realized. It's because my ledge jump does not check for the ground in the normal way. Well, maybe it does. Yeah, because actually, so this should update ground. This should update ground. No, wait, no. This should not update ground. This is the only one that should not update the ground, which means I should have... I should probably just have like a, like var exclude or like special ground equals state dot ledge, and it'll be like ledge ground. And what we'll do is if states in special ground special, we'll just call special ground state with delta maybe, nah, else update ground. So this way I can start simplifying this stuff a little bit. And maybe we can also have like some ground checks. So like we could have like, well, how do I want to handle that? This is fine for now. Basically, I'll just have a function called ledge ground, and it'll do nothing. So this way, everything will have its proper ground updater functions. Wait, do we actually check? No. Okay. So here we don't do that. But I think we actually do need to have in the real game best floor and like the player to be separate. I don't fully understand. Because it's clearly teleporting sometimes. By quite a lot. So I guess maybe I could do like if update ground. No. Grounded move. Let's do like if new position minus old position dot length greater than 0.1 break points. I'm also seeing some sort of broken jumps still. Yeah, look at that. Oh, I know why. It's because we need jump to if states timer greater than 0.2, return this. Okay. So what is our goal? What is our last transform? What is our new transform? What is all this stuff? Do we have like the actual like locals? Like this is not all of the locals. Like we don't have like old position and new position. It drives me nuts. I think it's that if you have an if statement, I'm pretty sure these these variables are not in the thing. Like they don't show up. So I guess what I can do is I can just do like that. And then we can try this again. Okay. Old position, new position. So yeah, we're moving like a meter straight up. So this is clearly a wrong thing. The local origin. So what was our last transform and what is our current transform? So I guess, where were we? Where did we go? So we went from air to ledge. So when we go from air to ledge... I have an idea. So what if we did states states. Round last transform equals so I think this should be, oh wait, I know what it is. It's because we should always be setting the ground update. So my movement code is wrong. Because we have our ground last transform here. This should be, that shouldn't be done there. That should be always done every time we update. So it should be like this. Ground last transform equals our new transform. No, no, ground last transform equals ground dot global transform if ground. So that way it's always set correctly, regardless of, because it doesn't matter what the state is. The ground last transform is going to be the last transform of the ground in the frame. Okay, there we go, I think. Admittedly, this ledge grab is pretty bad, but... Oh, wait. Hang on. There's some jank with it still. Wait, also, did we solve the problem of the ledge, the ground velocity being applied multiple times? I guess we... I need to figure out how to test that. Because my intuition is no. The only reason I'm not seeing it is because I've designed these states in such a way that you can't jump off of this very rapidly. But I think if I did something like this, and then we try it. So if I ledge grab here, and then we jump. Oh, we're on the ledge. Hmm. I mean, I think... How well does this work? Because, I mean, I guess it is doing here what it's supposed to do. Also, I'm thinking, do we need the ground local origin? So I don't think this is used anywhere. Because I think this is actually, I think this has to be continually recalculated. Well, I guess we do that with set ground. Yeah, we do that already. But okay, I think this test scenario will work, well, probably. Because I need also, I think, to test climbing. So let's say this little thing will also have a climb area. So it'll be, so like we get this climb area. So this will be climb. Okay, and this one actually we need to do some special stuff. It's like update ground like area equals ground area. And then like on ready bar ground area. And we'll have for here state dot climb or ground. So function and this will just do the same thing as update ground, except it'll use our climb area to determine the direction that we need to focus on. And then how do we do, I think this will be state climb. So do we actually use, oh wait, no, this is fine. So if not input dot is action pressed climb return state dot air elif. Actually, let's do this. And we'll also actually make this a ledge jump. And we should have an applied ground velocity or something. I'll see how this works, but let's do, for now, we'll just have it so that if input dot is action pressed move, oh wait, it's move crowd, right? So I'll just do this for all of these. So this is where a lot of the copy and paste comes from. So maybe I should also do here as a little test bed, figure out how to make this code less duplicated, and then bring those refactor ideas into the main code. Because this is one of the big problems with the code currently, is that if we go to the player, there's just hundreds and hundreds and hundreds of lines that are almost identical. And so maybe what I need is some sort of like state machine drawing system, but then I'd have to make it. Then I'd have to make the whole thing myself, and that'd be a mess. But it could be good. And I would like that. What am I doing now? I got distracted thinking about how cool it'd be to have a nice state machine, but okay. I need climbing, right. So when we get the next state, I think this all is going to be good. So it'll do basically state climb, jump, ledge jump. Otherwise we're in the air. Great, grand, beautiful. And then when we set, so when we act on a state, state.climb, we do let var vvel equals input dot get axis move down, move up, and we'll move or like climb move vvel times vector 3 dot up times speed delta. And a climb move will be almost, well actually, this should work just the same currently. So let's make a little test on the other side of this thing. So let's move this eventually. Like if I can select it. Hello? Camera? I'll select it manually then. Yeah, so let's get a little thing here. And this will be our test. So I should be able to hold left on the thing. So I can grab this, then we can climb. Look at that, beautiful. And then I should be able to climb on this just fine. So if I jump and then climb, look at that. And then that's interesting. What state are we in? What's our state name? Climb. Okay, so we're in climb. Oh, okay, so this is... We need to actually do... If we don't have a ground, we need to go to the air. So, climb. If not ground or not input held, oh wait, this is gonna be tricky. I know, let's do like If not, can climb. So then we can have climb, return, not climb area dot get overlapping bodies dot empty. So return, this is it, and that. Okay. So when we act on a state, I think maybe we need to act on a state instead of doing this. I think we need to act on the state in the game or in the frame, or maybe I know what to do. When we set the ground, or yeah, when we set the state for climbing, state dot climb, we need to get our climbing ground. Okay, there we go. So now it should have so now we should be able to climb up and down this thing, and then we can ledge grab, and then we can jump off, and it should be at the appropriate velocity. I still don't know why this is not correct. So let's just do let's just do that. And else it'll just do, I don't know why I don't know why we're in null here. Did I do an and instead of an or somewhere? Because this should be true. So basically, if we have, oh, I see. That's not really the case. That's not really the issue though. Because yeah, all of these are fine. Because basically, if we are holding the button crouch, here as well, and the climb area is not empty, then we do this. And otherwise, oh, I see. My refactor had gone wrong. So now it should be if we ledge jump here, it doesn't quite, it still doesn't really work right. But I think that's more that I'm catching on the ledge than anything. Okay, that seems okay. So let's say take your time, Git. So let's add areas tests. Add tools. Init m 20. No, not that. Test bed for movement refactors. And so what do I want to do with the player? Because let's add player materials. Add player base mesh. So this is just adding those things, right? Did I remove those on purpose? What is all this stuff? No, this seems like it's just nothing. Or well, whatever it is, it doesn't seem right. But oh well. I really like that effect though. I'm very happy with how that turned out. Okay, so let's just say updates to damage material. Oh shit. I did not mean to... Hang on. I didn't mean to do AM. I wanted to split out all those changes with the player, because I think I actually want to revert the player script changes. Well, I guess I can just do git checkout head -1 player scripts player, because this will basically unbreak the player. So let's see if the game works again. Let's not do that. Because, you know, I was trying to refactor, didn't really know what I was doing. So I just broke a bunch of stuff. So let's see if I've actually fixed this now. Okay, good. So now the game is back to being functional. And so I think when yeah, back to being semi-functional. And I think maybe I should be more generous with the bonk, because right now, if you bonk, you can't climb, and it just doesn't feel very good. Like, I don't think that's even a mechanic that I want. You know what? I'll just put that in the to-do list. I'll just remove the bonk. Actually, I don't even need to put it in the to-do list. I can just do state.bonk. And we can just do, like, we can just ignore this. Oh wait, I know what to do. We'll just do state.fall. So now, if I roll jump into something and I get into that state, I can just grab something. In fact, I could probably just do it, I could do it differently as well. I can still have the sound, but I can make it so that... Yeah, so this makes the player a little bit more powerful. And admittedly, I just did that in a completely busted way and then screwed up anyway. And look at that, gamers. And that's how it's done. And soon it'll even be possible for you to do that. I really like this damage effect. Very happy with that. Okay. I'm gonna say... unbroke the player. So bonk is removed, lead jumping on moving platforms. So let's say refactor the ground to be a refactor movement. So ground is handled script side. Simplify conditionals. So let's see, what would I do here to make this to make this simpler? Because we could do like, I'm thinking var conditions. And then it would be like, state.ground would have like jump and climb and fall. So these would be like all the conditions that we'll have. State.climb would itself have, oh, I know, hang on, wait. No, I think what I would do is I would have these in order, but it'd be like, if you can jump, then you do state.jump, naturally. If you can climb, then you do state.climb. If you can fall, you do like state.fall, or air, as I call it here. State.climb. So here is where the distinction, and why I made this distinction comes in, because here you do state.ledge jump. And then like match the state here. So this is going to be, or this is going to be like next state. So if we can not climb, we'd probably just have to have, well, what would we do? Let's make a very poor man's Lisp here. Or maybe we would do, I know what we could do instead. We can do like can climb, good jump, should fall maybe. So then for like state.jump, after so this is basically like a conned expression in Lisp, but just very badly done. Maybe I should use scheme. That'd be fun to add scheme support to Godot. And then I guess these would all have, like... This would maybe have, like, a default thing. Well, I know what to do. No, actually, I don't know what to do. Basically, what I'm thinking is, it goes through, so like it picks the list for your current thing. Then it calls each of these functions. So like, and the first one that succeeds, it returns that. Otherwise, it returns ground. And then default would just be true. So state.air would be like ground. And climb state.climb. Oh wait, and then like can grab ledge. State.ledge. And this one just has can climb, no, could jump. States dot ledge jump. And then state dot ledge jump would have like our after states time, no, after 0.7 oh, this one's gonna be tricky because we need our, oh wait, I know, before 0.7 we just return state.ledgeJump. Otherwise, grounded state.ground. And the default will be air. Oh wait, I know. Can climb state.climb. So now we have an interpreter inside of an interpreter for the world's worst language. Oh, that's not quite what I want. Because Godot was just too dang verbose. So now what we can do is we can just process like let con or var cond equals states dot no next state for cond in cons if so like var ex equals on 0 or next if true equals on 1 if ex is array call ex dot, can we do like a call b? There we go. ex, and then ex dot pop. So this should be... How do we pop the first value? Or can we, like... Okay, so we can pop run. There we go. And then else... or res. If res return state. Okay. So now this is all of the function in here that we need for this. So we need some sophisticated logic. So like should jump is return input dot is action just pressed move. What do we need? Move jump. And then should fall can climb. Should fall return not ground or ground dot normal dot y less than 0.2. Or maybe I should just do, for now I'll just, well, I'll keep this as it is. Like maybe we'll do like something. And for ledge ground we'll do, oh no. Let's do like for climbing ground. Ground normal equals vector 3 dot up. Okay. So that'll just be something that we do for now. Because I don't want to bother making an extra function for different condition variations of should fall. So can grab ledge. Return ledge cast dot is colliding. And then function default return true. What else did I need? Before and after. Before time return not after time. After time return state timer greater than time. Should fall can climb default should jump after grounded. That's one that I haven't had. Ground and ground normal greater than 0.8. Okay, let's see if this still works, because this would be interesting. Oh. Oh, not Y. Almost. Act on state. Should fall. Let's start in state dot air. Wait, no. Hang on. When we run this, set state, so get next state should be working properly. Let's try this. So let's run this again. So what is cons? Should jump, can climb, should fall, 1. Okay. So res is false because ex is should jump. Ex is can climb, so we don't have that. Should fall, let's go into this. So we have no ground, or that. So this res should be true. So then we return state 0. Oh wait, hang on. That's what we did. Okay, so it wasn't something complicated. It was just I just messed up the basic thing of I was returning the same state that we already had. Okay, so now we don't need that. So then we fall, then we jump. Invalid type in function call v cannot convert argument 1 from float to string. So ex is empty. Let's go back to cond. Oh wait, it's because we're getting this by a reference. Hang on. We can't pop this. We need to do call v ex dot like so we need to get a copy of an array, like a slice of it. Duplicates a subset described in the function and returns it in an array. Deeply copying the array if deep is true. Lower and upper bounds are inclusive. Let's see. So yeah, it was about 7. I wound up working on it for about 7 hours continuously, which is not uncommon. But yes, you should take the shots at least once a day. Okay, so what I need is ex.slice 1, ex.length -1, size -1. Let's see if this is correct. Not quite. Oh wait, this is 0. It is. I was joking earlier today that it basically feels like I have a hangover. Because I just stayed up so late working on it. And I'm not even at the hard part yet. I haven't even made the call by name conventions. Like, I didn't even implement closures. I just have, like, very basic function pointers, and it just took, like, 7 hours to do. But okay, this looks okay. So I've basically made the world's worst Lisp. So how do I make this not so bad? Because I guess I could make another little language that just compiles down into this, and then I can just read from this. Because it would be like... probably be S expressions, because they might as well be. Well, what would I actually want? Maybe like... rounds... So yeah, let's draft up another little language, because I think that's what the world needs. Oh yeah, and call by name conventions, they are basically from a cult. They're indecipherable. And extremely powerful to the point where people realize, like, we should just, like, make this an explicit thing rather than something that you can accidentally do. And actually, if I'm doing this, I could just do, like, not can climb goes to air. Yeah, it's more about reducing the visual noise. Because this, admittedly, isn't semantically that hard, but it is sort of, it's just a lot of typing. But I guess, admittedly, the amount of work that it would take to create another parser and the amount of complexity that it would add, it's almost certainly not worth it to do something like this, but it's fun to fantasize about. Because honestly, it'd be much easier to just make like a visual diagram, almost. Yeah, that actually probably would be easier. I could look at my tutorial back from way back when. Yeah, I think maybe just for a start, I could try refactoring the player in the main player into something like this. So that way I have just a lot less stuff that I have to manage, like in copy and paste and stuff. Yeah. Yeah, because I guess I could figure out if I can just parse this. So how would I do that? Because I guess I could actually do ground, climb, jump. Jump, climb. Let's get some more music in here. Interesting. Yeah, because I think the aesthetics of a language can help a lot with figuring out what you want to do with it, or expressing things in it. Because like I also really want lambda expressions in Godot 3. Yeah. Yeah, because I think this is fun in concept, but I don't think I would implement this. Well, yeah, because I'm thinking even just having another resource that I have to juggle around would make it not worth it. Because I could make this parser probably pretty quickly. But it wouldn't be there. Yeah, because I think I should also make sure that, for example, all of the values here are expressed properly. Something like that would be interesting. I wonder if this is more removals or added. So we've added a bunch of lines and not really deleted that many, but I guess it's okay. Man, this does make it a lot more compact, maybe. Because I could also do things like have the various properties of the array in here. Actually, we can make this a constant. Yeah. I think you're right. I think that it's just not going to be, you know, because it's not like my dialogue where it's like I have thousands and thousands and thousands of lines. It's more like, you know, because even in the player, there's like 24 of them. Though admittedly, there are a lot of states in the player. In fact, let's start. I'm going to do a minor thing where I just make some of these, like I'm just going to bring these together because a lot of these, I don't really benefit from having all of them laid out like this. So let's have like crouch, roll, climb, jump, roll, fall. Let's have these two associated with each other. And like roll, bonk, fall is tied to this state. It's like I would put these together. Because like I don't need to scroll past like 100 lines. Let's do like wave jump, wave roll, sitting, dash, high jump. So a high jump is related to diving. So I'd rather have that here. Wall cling and wall jump are related to climbing. So maybe I should have climbing as a distinct state. Or like its own line. Sitting and dashing are there. Hover. I guess I'd put vehicle with hover. You know what, I'm gonna start attempting to express my next functions in here. So let's actually get this in GDScript, or in here. So yeah, goodbye to this. We need the player scripts. And we're going to have an extra one of these. right, here we are. So yeah, let's try making this. So it'd be const next equals state.ground. So like should jump to state.base jump. Should hover should route or like holding. Well, what do I want with this? So this one is a little tricky because this functionality here is better expressed in code. So what I could do is just let's just do like check route. So it wouldn't even be an array, it would just be this. And then like maybe I'll just have a special thing like eval. So like here, it would take a break, and it would just evaluate whatever code I have custom for this particular branch. It's a very messy thing, building a scripting language out of a scripting language. So non-empty crouch head and standing collision disabled. We would go to crouch. So I guess let's just do combat lunge. Combat spin state dot spin kick What can I do to make this better? Because maybe I can, because I'm seeing now that because there's so many variations of these things that like I could reduce 4 states or 4 of these state transitions very easily. But that doesn't save much code here. Because maybe what I should just do is just do this. Or actually what I know what I could do. So let's make it so that next state equals get next state. And then we're going to hide this. And then we could actually even do set state. Yeah, because I tried my best to make it, because I was basically trying to solve this problem already. Alright, so let's go to set state. Function get next state. So what we can do at least is we can just return. Oh. So here I can remove a little bit of this line noise. Oh god. Okay, so once we get to state place flag, I know to be concerned. And then if we don't match any of those, we'll just return state. So I just want this code to be a little bit more... Well, that's not really going to help me here. I think maybe just having this as a separate function will be good enough. Let's go back to Godot, and let's see how that's going to work. There we go. So, let's see what breaks from this. Where the hell do I define speed? Oh wait, why is my... Oh, because that's there. Okay, so if we go here again... So we need movement as well. Is that a vector 3? Past argument type. Oh. Okay, so this is a vector 2. So do we do... So I think this... We can just do that here. So we're just going to do movement, max depth. Vector 2, max depth. Float. And then we can return crushing death. Return die, and let's spawn return. Well, what does this do? Because currently, so what does respawn do? Okay, I guess we can just return state.ground here. So let's not even bother with that for now. Well, I know what to do. Return state.ground, or like, let's do return die here. So when we die, we're just gonna call deferred. And we're just gonna respawn there. Okay, yeah, so it's a parser generator, I assume. Wow. That seems like it'd be pretty powerful. See, I think it'd be fun to make a scripting language that focuses on being like as terse as possible. Now that I've been looking at this for a while. Let's see, isn't declared in the current scope, so we need best floor dot. Which I guess... Alright, so let's go up to here, and let's comment this out, and let's see what happens. So let's resolve all this stuff here. Because we need things like average normal. Which I think a lot of this stuff isn't actually used in other functions. Okay, so I would need to give our movement max depth, best floor dot, average normal, current normal, desired velocity, and delta. So is there a way that I can better express this so that I don't have to pass in a billion parameters to this function? Because I think some of these I can compute from within. Like, I don't think they're actually used in here. Like, let's do like best floor dots. Let's go up, actually. So we're in the 1500s, so best floor dot equals max blah. Okay, so best floor dot is not used anywhere else. So we can actually just get this as a derived value inside of this. So that's one variable that we don't need. Okay, and here we do actually start having these. Ground normal, average normal. So yeah, average normal is required, so we would pass that in. Current normal, though, is also used sometimes. So why does wall cling use current normal rather than average normal? Was there a reason for that, or did I just forget about it? Okay, and then otherwise current normal is just used as an argument for this. So we can just do this. Oh wait, and then that, and then bring this in. Current normal already defined, so we don't need that in here. Mm-hmm. And do I use max depth anywhere other than here? No, we just derive it when we okay, we just derive it when we do our calculations as well. So I think we can do this stuff in here. Well, no. So this needs to be preserved. Not because we need it elsewhere, but because we just need it, or because we calculate it while we're getting our collisions. Do we use best floor anywhere other than inside? Oh wait, we already have the best floor actually. Okay, let's see max depth. So we need average normal desired velocity delta. Five parameters to a function isn't that bad. Oh, I mixed it up. Okay, max depth, average normal. Oh, desired velocity delta. Okay, so that removes some of the scrolling that I have to do from the top to the bottom. And then we could do maybe state.ground. Let's try to refactor these, or maybe we can do like a just act on state here. Wait, what are these as well? Okay, applied ground velocity and stuff. On state delta. So I know we'll need desired velocity and delta. What did I do? Oh, for some reason, there we go. So I need all of this stuff. Well, I guess this stuff isn't that bad here. Oh, there we go. Act on state, and then it'll be like desired velocity vector 3, delta floats. And let's do the same thing here where we just comment this out for now. And I figure out what I need for this act on state function. Oh, that was all. I only need the desired velocity, average, normal, and delta. Okay. Easiest game of my life. Oh, average. So what are these for? So now also, I'm going to refactor all of my debug stuff because I just developed my sophisticated new thing. So let's do like, I know, let's go up to the debug node and let's delete this. Because now I'm just going to go through all of the references to this and just remove all of this code from in here. So anytime I want something, I can just add it into a function or like a property of this thing. Yeah, because we can do like states. Well, I'll just leave that as it is. Unreachable code. Oh. Thank you, Godot. It's weird that that's... Oh, it's because I copy and pasted this exact code in multiple places. Oh, wait, but now I can do, like, return sit, or returns... yeah. This language should have monads, so that way I can have, like, a monad where if the value is true, we return, otherwise we continue through the tree of execution. So that way I can make this extremely terse. That'd be fun. I should make a... There should be a game engine in Haskell. Or maybe Haskell as a scripting language. Instead of having... Well, I guess you'd probably inevitably do that, because so much of the logic would just be in, like, bindings to C that you might as well treat it as if Haskell is a scripting language, and, like, the entire rest of the game is built on, like, C++. No, just C, actually. Because then you have to do C++ C and all that stuff. I see. The game is not quite functional. So let's get my debug. So it'll be good to see. So where's my little debug window? We need a debug property. So let's just delete all of these for now. So let's have like state name, state, so we don't need this anymore. I'm just going to always have in so state name equals State.keys state. So this will show us what's going wrong here. Because it seems to be just related to death, which makes sense. Invalid get set to... Oh. Debug UI. Oh, right, okay. So we need to not have this here as well. Because yeah, we had a million billion things that were all managed centrally by this UI. Let's not have that at all. And also our little debug property thing, so it should have like a set process is visible in tree. Notification what if what equals notification visibility changed, then set process is visible in tree. And now I should be able to do this. Oh. Yep, node. Debug. Not quite. Oh wait, it's UI. Ah, okay, hang on. Let's just go back. Let's undo this. So let's do UI. Let's get the debug UI in here. Onready var debug equals bug slash okay, gaming slash debug. So now we can go to here and we can do ui.debug.visible equals show stats. And it will probably execute. There we go. So we have some issues I'm seeing. So let's see, set next, so get next state. So when we are in state dot base jump, I have an idea. That's not what I want. I want this to be timers, I think. Yeah. Actually, I wonder if I can add them while I'm running the game, or if that'll be too much for Godot. Okay, so we have timers. So none of them are being updated. That's useful to know. Okay. So we should have this. Oh, I know what it is. Set state, get next state. Because we don't do this. So let's do like, I forgot that this is how I set this up. So let's do get next state. And let's get the last variable. So let's make this the same as it was before. So let's return state dot none. So for next equals get next state. So if next not equal to state dot none, we'll set the state to next. Otherwise, we will act on the and then we act on the state. So that explains that. All of our time-based animations were incorrect. That's what I get for refactoring semantically different behavior without thinking about how to do it. And admittedly, that none of this has actually fixed the core issue that I was meaning to fix, which was how to best refactor the ground movement. But at least the code is shuffled around ever so slightly, so that it's a little bit easier to figure out where things are. Let's make this... I don't know which one I prefer. I'll keep it like that. Yeah, spin up that hard drive. Okay, so I think this is now explained by my little test scene. It's a little green field. So the next step will be to make the ground work the same way, even if I couldn't make this funny little change. The world's worst Lisp work for me. Refactored the player to be way less cringe. No. Refactored the player code to be a little easier to read. Wait, I somehow deleted 100 lines. Oh, wait, I guess it's over the course of multiple files. Oh yeah, because I also deleted all of the player's debug code. Because I'm just going to slowly add that back in the nodes themselves. Because that'll be... Admittedly, it's probably worse for performance to have all of these nodes that'll update every frame. But it'll be just so much easier. And plus, I can just make it... You know, I can just delete it for the export. Actually, that's a really good benefit of this, now that I'm thinking about it. Because these, I can just trivially delete them. Like, I can delete the whole window, even. And then it'd just be gone for good. Where otherwise, I have to go through all of my code refactoring all of it. Let's make that a bit smaller now. Made the window a little small. Okay, so there's nothing too crazy this time. It's still mostly coding. And I think tomorrow... Am I streaming tomorrow? No, I'm streaming Sunday. Maybe tomorrow I'll do a lot of code stuff and try to do this refactor, and then on Sunday it'd be more level design. That'll probably be my plan, because I think I still want to keep it a mix of coding and like the modeling stuff. But who knows? See you later.